Hello and welcome back to the second part of 7.4 geometric sequences and series. I am not on camera this morning. I am definitely not camera ready. It is 5:20 a.m. when I'm recording. And yeah, so today we're going to look at what is a geometric series. And a series is just a sum of the terms in a sequence. So the sum of the first n terms, we would say S sub n. A geometric series is the sum of the terms of a geometric sequence. So if we are given a1, r, or n, this is the one we'll use most. This is if we had the recursive formula for the series, we would use this formula. But for the most part, we'll be using this one. So this is a formula you'll be using a lot, this section, where the sum of the first n terms would be the first term minus the first term times r to the n. Remember, r is your common ratio over 1 minus r. Now we can also write the sum of a series using sigma notation. This is the capital Greek letter sigma. So Greek letters do come in upper and lower case. This would be the uppercase sigma. And usually you'll see it written kind of like this, where you'll have a number at the bottom, which tells you what the first term is that you want to add, and then the last term that you want to add, and then kind of the rule for the sequence. So this is an example for an arithmetic. Here's a geometric that we'll look at. So for instance, this means I want to add up the first 8 terms of the sequence. From term 1 to term 8 would be 8 terms. So we could plug in 1 for k, and 2 for k, and 3 and 4, all the way up to 8. And figure out what all these are and add them up. But we're going to do this using the sum formula we just looked at to make it easier. But that's what this means. This means we're going to add up the first 8 terms of this sequence, defined by this formula, where we would just plug in 1 through 8 for k, evaluate, and add that all up. But again, this is really easy to do with the sum formula. So let's look at this here. Kateri wants to set up some dominoes so she could knock 1 over, which knocks over 2 more, which knocks over 2 more. So every time we are multiplying by 2 here, if she wants to make 6 rows of dominoes, how many will she need in total? Look at that. So satisfying. So how many dominoes does she need? So basically, if you think about it, all right, let's move this so we're not distracted, or so I'm not distracted. There are 6 rows. So the first row, there's 1 domino, and then times 2, times 2, times 2, and so on and so forth. So if there are 6 rows, then the first row is 1. The common ratio is 2, and we want to find the sum of the first 6 rows. So we'll start with our formula, and let's just plug in the values. And from here on out, it's just evaluating. So if you have all these values, you just plug them into the formula and evaluate, and you get 63. So we would need 63 dominoes altogether. Now, if we want to find the first term in a series, so find the first term of a geometric series for which the sum, so now in this case we're given the sum of the first 5 terms, n is 5, so the sum of the first 5 terms is this, and we have the common ratio. So again, just start with your formula, plug in what you know. We know S sub n is this. We don't know a1, that's what we're solving for, but we know r is 1/2 and we know n is 5. So plug in everything we know, and from here on out it's just a little algebra and simplifying. 1/2 to the 5th is 1 over 32, and then this is like 1 a sub 1 minus 1 over 32 a sub 1. So if you think about it, this would be 32 over 32 minus 1 over 32, because 1 is just 32 over 32, and that's where this 31 over 32 comes from, in case you're wondering. We're just combining these like terms to get 31 over 32. And then to simplify, 31 over 32 divided by 1/2 would be times 2 over 1. And we can cross cancel here to get 31 over 16, and then multiply both sides by 16 over 31. Use your calculator, and you will get 11 for the first term. So the sum of the first 5 terms in this sequence is 21.3125. The first term is 11. We're multiplying each term by 1/2, adding all 5 of those up, and this is what we would get here. the sum if we have this in sigma notation. So let's first think, this would mean I want to find the sum of term 5 through term 12. So I would have to plug in 5, 6, 7, 8, 9, 10, 11, 12. And if you think about that, count it, 5, 6, 7, 8, 9, 10, 11, 12. How many terms is that altogether? If you think about that, that's really 8 terms altogether. So I'd have to plug in 5, 6, 7, 8, all those, and then add them all up. That can be kind of a lot of work. But what we can do is from this, we can figure out A1, R, and N, and then that will help us to use our nifty little formula to find the sum much more quickly. So let's see how we would do that. Let's just say, instead of like, technically this would mean like the 5th through the 12th term, but we could treat k equals 5 as our first term. So our first term, we will just plug in 5 for k. So 5 minus 1 is 4, negative 2 to the 4th is 16, times 3 is 48. So we'll treat this as our A1. Our A1, our first term, is 48. And then R is easy. It's this number with the exponent. So whatever the base is, that's your R, because we're multiplying each term by negative 2 to get the next term. Then N, if you think about it, 12 minus 5 is 7, but like I said, this is really 8 terms, so we'd have to add 1 to that. So there's 8 terms, because 5, 6, 7, 8, 9, 10, 11, 12, that's 8 terms altogether. So now we have A1, we have R, we have N. A1, R, and N, plug those in, and then again, calculator, 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 and the sum of those 8 terms would be negative 4080, which is a lot easier. If we can figure those values out, it's a lot easier than plugging in 5, then 6, then 7, then 8, and all of those and adding them up. So if we can just figure out the values we need here, then the sum of those terms will be negative 4080. And that is really all we have for the second part. So you're just working with some new notation, and that sum formula you'll be using a lot, but that is all we have for today. So hopefully that makes sense, and if not, we'll talk about it in class tomorrow.